Okay, and in this video we'll go into problems 41 and 43. Again, we're trying to find all relative extrema, and we want to use the second derivative test wherever we can. So let's get right down to it. Number 41, we have f of x is equal to x cubed minus 3x squared plus 3. Our first derivative will be 3x squared minus 6x, and we can factor that, factor out a 3x, and that will leave us with x minus 2. So that tells us we have zeros at x equals 0 and x equals 2. Next, we want to find the second derivative. Second derivative is, second derivative of f at x is 6x minus 6. So all we want to do is plug in, if we can, f prime prime of 0. We get negative 6, so that would be concave down. And f prime prime of 2, we're going to get 12 minus 6, positive 6, and so that will be concave up. So let's summarize this. F prime of 0 equals 0. F prime prime of 0 equals negative 6. Therefore, f of 0 is a relative max. Alright, f prime of 2 is 0, and f prime prime of 2 is positive. Therefore, f of 2 is a relative min. Right? Once again, because we have a horizontal tangent at 0 and the function is concave down there, therefore it must be a maximum. At x equals 2, we have a horizontal tangent at 2, but the function is concave up there, so it must be a minimum. We'll go on to number 43 now, and you could graph these functions and verify that yourself. Number 43. We have x to the 4th minus 4x cubed plus 2. And that's f of x. Alright, so then we'll find the first derivative. The first derivative is 4x to the 3rd power minus 12x squared. And we'll want to find out where that's 0. Well, let's first factor out a 4x squared from that, and that will leave us with x minus 3 equals 0 when x equals 0 and x equals 3. Alright, so let's see what happens here. We'll go on to the second derivative then. Second derivative of f at x is 12x squared minus 24x, and we can factor that to be 12x times x minus 2. So all we have to do now is plug in. Let's try f prime prime of 0. Well, when we have that, we're going to get 0, so inconclusive. The first derivative is 0 and the second derivative is 0. Let's see what happens at x equals 3. Well, at x equals 3, we're going to get positive times positive, which is positive. Doesn't really matter what the value is. And so that means that we have a first derivative, 0, second derivative, positive, and so we have a relative minimum. So f prime of 3 equals 0, f prime prime of 3 greater than 0, therefore f of 3 is a relative minimum. Now, the second derivative test was inconclusive at x equals 0, so we're going to have to do a first derivative test in that case. So, not a lot of fun, and sometimes I feel like I could have done the first derivative test and just gotten the answers that way. 0 and 3. Again, we're working with the first derivative here, since the second derivative test was inconclusive, and we go back to a -1, a 1, and a 4. Now, we need to plug into the factored form of the first derivative. At -1, we're going to get negative. At +1, we're also going to have negative. And at 4, we're going to have a positive, which means that at x equals 3, there is a relative min, down, down, up, but you can see that there is no relative min at there is neither a min or a max at x equals 0. So, could we have told that just from the second derivative test? In fact, or the way that it is defined, the second derivative test is inconclusive when the second derivative is 0 at that point. So we have to go back to the first derivative test, but we were able to find out what we needed from that. So we'll stop this video here.